Okay, again, kind of rushing into this because of time constraints, but, okay, now the charge is what? It's 9 times 10 to the negative 7th coulombs. Because you have 10 to the negative 6, and you've taken 10% of that off, right? That's going to leave you 9 times 10 to the negative 7th coulombs. If that's not immediately obvious to you, and it might not be, think about it, and it will be, okay? Yeah, work it out. Work it out with your calculator if you have to, but then get it into your head how the powers of 10 work, right? Something you got to get used to. And at this stage, I don't expect you to be totally adept at that, okay? So your charge is 9 times 10 to the negative 7th coulombs. Now we want to transfer, now on the document here, I say transfer 10% of the charge, right? What I really meant to say was transfer 10% of the original charge. In other words, another 1/10 of a microcoulomb, right? Okay, well, what's the kicker here? You would think, well, it should take another 9 times 10 to the negative 5th seconds. But that's not so because the charge is only 90% of what it was. Well, what does that do to your electric field?
It decreases the time.
Okay, so now electric field, or now, okay. The field is 10% less, so the voltage is 10% less. Now you want to really think about why that is. So the field in the wire is 10% less. So the current is 10% less. Okay, you got this whole chain of reasoning. Make sure you understand every step of that chain. But if you've got 10% less charge, you've got 10% less field because the field is proportional to the charge density, right? So you got 10% less charge over the same surface area, you're going to have 10% less the surface charge density, which will give you 10% less electric field, which gives you 10% less voltage, which gives you 10% less electric field in the wire, which gives you 10% less current. Okay? So I just repeated what I said, but you know, hopefully that re-emphasizes it. And then it takes 10% longer to transfer the same amount of charge.